we are going to investigate this program, and we'll see how we can exploit this program using the vulnerability that is uh, existing within this program. So if you can see here, we have the sprintf, which takes the user's input, and we call it like ID. They can, or the users can input any string, because it's char, and it's appending that ID or whatever inserted by the users to the records. Then we are constructing like a variable inside the path. So now we have to look into the path and see where it exists in the memory, and we also would like to take the advantage of changing the RIB of that, the return address of the check, because the check is called from this area, and once this check is finished or completed, then it will go back, or the control will go back to the printf. Either if it is right or true, it should print the first one, and else the second one. So the we'll take the advantage of that by inserting in the sprintf some of the values that make stack overflow, and then we change the RIB, or the return IB of the instruction, to call the when functions. Alright, so let's have a look into how stack overflow can take place in programs. So this program was compiled with no stack protectors. I'll go now and make the okay, so session should be nested with care unset. Alright, so I already have that on. Let me go now and divide the screen. The next thing, we're listing whatever we have there. Alright, nice. Alright, good. So now I'll go with the obj dump and see what is the inside the binary file. So the binary file should have some of the interesting things here. The first thing that we're looking for, the when address, where the when function address. So it's here. This is the when function address. Alright, that's what we are looking for, because we want to overflow the RIB, or to replace the RIB inside the stack with the when address. Alright, so next is quit that and control B, then alright, that's should be fine. Now I'll use the GDB to make the debugging. Alright, so I can move it a little bit there. It's not moving. Alright, so yeah, should be fine. I'll go with the anyway, I have the check functions there, so I want to make a breakpoint inside that check function. So this is the breakpoint. Next is to run the program, so I'll go with the run. So it says welcome to CPCS653, type your first name. Alright, so I'm typing my first name, A. Alright, next I will now look into some of the interesting thing inside the check. We are in the beginning of the check, just in the check plus 4. Right, I'll make this a little bit bigger. Okay, so now it should be nice. Alright, so we have the RSP, or the starting address of the RSP. It is almost like 70, and also we have the hexadecimal of 50. That's like reserving some space in that for the uh, for the variables. Alright, I will go next um, with the execution. Alright, so now we are inside the check plus 8 that is moving this variable which we inserted AAA into this pointer, and this pointer is available into this address. So let's go and investigate that, whether it's been there or no. Alright, I'll just move one step further and then I will do it. So I'll just go for GX, then I will check into what we have inside this address. Alright, so we have this pointer. More, we can just see what is inside that as well. Alright, not that one, but this one. So we have 61. What is that? 61 is the ASCII value of the small letter A. Okay, and this saved using the hexadecimal. Alright, so now we need to know what is the path of that. What is the path of the or what is the address of the path variable? For doing that, it's a little bit tricky. We cannot identify it or identifying it now because we are still in the beginning and we have it as a pointer, so it's still not where it's unknown to us, like we don't know where exactly it is, whether it is this variable or this address, which is the 78, the first one, or it is the second one, which is the 80, or maybe A8. So we are not sure yet where it is. Alright, so I'll move forward until I get the load or the LEA, which is loading the exact address of the path. Alright, I'll move forward until I reach to the LEA. So now we have it. We are moving this address or the RAX into this address, and we are giving it like a 0. Now we will have it inside it, or nothing will be there inside it. It will be like a 0, and we can see that also it's giving the RPP plus the REX. It's like whenever we are loading the destination address, it means that the path of that or the address of that path variable should be the whatever we are indicating into the REX. If we'll go also with this one and investigate what's inside it, sorry, we'll find it like 0 because it's all set to 0, so that we are preparing it for or to be pointing to the path variables. Alright, so now we have this one as the first variable that we need, the second or the first path that we need, or the first address. I should have changed the name of the path to something different. Alright, so now the info frame, we have it like this one. Okay, so now we got the address where it is returning to, and we should be knowing that this address, like the RIP, it's having this address inside it. So if you can go with the when functions in the main, you will find it inside the main, or this address should be in the main because it's 412. Now we are in the when, which is in the first or in the beginning of our program. So the 1266D should be the functions after the check immediately. So we want to overflow this or override this address with the address of the when or the when functions. Alright, now we have the RIP, so I'll just copy that and I'll go to the next window here and I will type IPython. Otherwise, if you have Python, just you can do that. Alright, so I'll paste that one minus. Now we have this address, okay, which is the, alright, let's see what is inside that 72. So now we have this 72 is the calculation of the RIP minus the path. So it means that since we take the or the starting of the path is this address, which is the 80, and until we reach the RIP, the beginning of the address of the RIP is in this place. So now we want to make or to overflow this entire area, which is the 72 bytes, with anything. Until we reach there, we can add some of the things that we want to transfer the flow of the program to, and in this case we have the when function. Alright, so before doing that, we have something which is, if you can see inside the program, now inside the program we have this function. Alright, we have this, not functions, but this text, which is also included in the counting, because whatever we have in the ID now, it will be attached to the records, and all of this together will be inside the path. So it means that this is the initial word, which is 1 2 3 4 5 6 7 8. So we have now 8 characters inside the path already, and that should be minused from the 72. If we go with the 72 minus 8, we should get 64. Alright, so this is the 64, and we have the address of the when. Alright, so now we are using the little endians in the program. How we are changing the when functions address in hexadecimal to little endians. So to do that, I'll just copy paste the entire thing here, 0x, then I will write dot 2. It's good that it's already there, and enter. So now we have the alright, so we can take that one as well. So this is the path that we want to construct. Alright, so we have the 64 and we have this path, so this is all we need from this program. Alright, the next step is to you can quit this program here, Q. Alright, and we can do the Python 3 stuffs, Python 3 minus C. This is like giving the command, and import system, then system dot stdout dot buffer dot write, and now we have to, okay, I'll give the A plus, not plus, into how many times we want to insert the A inside the program, 64 times. So I'll go with the 64 times plus, now I need to add in the last the address of the when functions, because this I want to have it inside the RIP. I'll close that. Alright, then I will close the double quotations of the Python. Then I will give these pipelines to the program called stack that we were in. See whether we can call the function when or not. Now what we can see here, like welcome to type your first name, and says your participation is not, can only concatenate str and bytes. So we have something wrong in this, which we have the byte here. We have to add the byte, because the A we didn't specify that is a byte, so we have to write a byte here. See what we have here. Alright, yeah, So we are inside the when functions. We call the when functions and we get the flag.